All right, welcome back. If you remember last week, we were able to take a quadratic function in standard form and convert it to vertex form. And then we were able to take the vertex form and use it to be able to find the vertex, the axis of symmetry, and whether or not our function or our parabola was opening upward or downward. Now what we're going to do this week is we are going to leave the quadratic function in standard form and we are going to figure out how to graph it while it is in standard form. It's not, to me, it's not quite as simple as using vertex form because vertex form very obviously indicates the values for the vertex and the axis of symmetry and whether or not it's upward or downward opening. But when we're in standard form, it's a little bit more challenging because we have to use this formula to find the x and y values of our vertex. And the formula is right here. We're just going to think about negative b over 2a. And when we have our function in standard form, the a and b are just the coefficients on the x squared and the x term. So negative b over 2a is our x value, and then to find our y value, what we do is we just take that x value and we plug it into our function, or we evaluate our function at that x value to find the y value of our vertex, and that's represented right here. And then axis of symmetry is the same as it is when we have vertex form. It is just the x value of our vertex, and so you can see that here. And the value of a, whether it's positive or negative, still determines whether or not the parabola opens up or down. All right, I think the best way to do this is to just take a quick look at an example. So if we want to find the vertex and axis of symmetry of this function, the first thing we just need to do is identify what a and b are. We don't really care what c is because c doesn't come into play in the function. So we just need to identify a and b. So we have an a that's 2 and a b that is negative 16. And then to find the x value of our vertex and the axis of symmetry, all we have to do is plug those two things into negative b over 2a. So if we do that, negative b over 2a becomes negative, and then we have negative 16 on the top. So this is where it can get a little bit tricky, and then the bottom is 2 times 2. So whenever we have a double negative more or less, it becomes positive, right? So this is going to become positive 16 over 4, and we can simplify that to be 4. Okay, so we know that the x value of our vertex is 4. So I'm going to go ahead and write that over here. So the x value of our vertex is 4. That also means the axis of symmetry is x equals 4. All right, so now all we have to do is find the y value of our vertex. And we're going to find the y value of our vertex by taking that 4 and evaluating our function at f of 4. So here we go. We're going to plug a 4 in there. And then anywhere there's an x, we're going to replace it with a 4 in parentheses. And we'll do some evaluating. Okay, so f of 4 is equal to 2 times 16, right? So 2 times 16 is 32, minus 16 times 4, well, that's 64. And then we have plus 33. And then we just have to combine those three, so we end up with f of 4 is equal to 32 minus 64 is negative 32. Plus 33 is going to be positive 1. So we're going to go ahead and plug in positive 1 for our vertex. So the y value of our vertex is positive 1. And then we can go ahead and graph that. So we're going to go ahead and graph this function. So we know the vertex is at 4, 1, so I can go ahead and plot that point here, 4, 1. So that's my vertex. And my axis of symmetry is the line vertical line that runs through that point. So I'm going to go ahead and just use a dashed line here. And then since A is positive, we know that our parabola is going to be opening upward. So I'm just going to go ahead and draw a rough sketch of a parabola that is facing upward. All right, let's do another one. The second one here, we have a couple of negatives that we're dealing with. So if we follow the same process where we identify our A and our B, we have an A that is -1 and a B that is -8. And if we use our formula, -b over 2a, and we plug in the b and the a, we have -8 over 2 times -1. So we got a whole bunch of negatives going on here. And one of the things that I like to do is just count up the number of negatives. In this case, there are 3 of them. And anytime we have an odd number of negatives means that it's going to be negative still. So I know that this is going to end up being negative, and it's going to be 8 over 2. And then 8 over 2 is 4. So we ended up getting the same x value. That's just well, actually it's negative, so it's a -4. But we got a 4, which is just coincidence. We're not always going to get 4. And so our vertex in this case, the x value of our vertex is -4. And our axis of symmetry is x equals -4. And so we're going to go ahead and figure out what our y value of our vertex is by evaluating the function at -4. And this one is going to be a little bit tricky, and it's going to be something that people are going to make mistakes with. And as long as you learn from those mistakes, you'll be all right. So the part that's tricky is the very first term. We're squaring a negative number, and I've seen a lot of people square a negative number and keep it negative. And we shouldn't do that. Whenever we square a number, it doesn't matter if it's positive or negative, it's always going to be positive. But in this case, since we have the negative sign in front of the x squared, that means that no matter what number we plug in for x, we are going to get a negative answer out because it's telling us it's negative x squared, or it's the opposite of x squared. So we have f of -4 is equal to -16. And then this one is going to be +32 and then -13. And then we just need to combine those 3 terms. So we have -16 plus 32 is +16. And then so that 16 minus 13 is +3. So our y value is 3. And in this case, the a is -1. So that means we know that our function is going to be opening downward. And so we're going to go to -4, +3. And so that is our vertex, -4, 3. And then our axis of symmetry is the line that just runs down through it, vertical line. And then since it's opening downward, we'll just create a rough sketch to represent that our parabola is opening downward. All right, so that was a couple of quick examples. And it's relatively straightforward if you can evaluate a simple formula and then evaluate a function at a specific number. So you have 4 to do on your own here. When you're done with these, make sure you submit it to Schoology so I can take a look at it for you.